Assalamualaikum and a very good morning to Puan Nur Aiwan binti Rosman. I'm Muhammad Faiz bin Khalid and my group mates Muhammad Akmal bin Zulkifli. Today I'm with my group mate representing definition, relevance between cardiovascular system and aging, and prevention of cardiovascular disease with the title of cardiovascular aging. First of all, I would like to give you an overview of cardiovascular system. Cardiovascular system has a very important function, which is getting oxygen and nutrients to your entire body and removing waste. Your cell depends on your cardiovascular system to get what they need to keep running smoothly. That's why it's vital to take care of your heart with exercise, a healthy diet, and control blood pressure and cholesterol. In details of cardiovascular system, the heart and many blood vessels in your body make up the cardiovascular or circulatory system. The heart uses the far-reaching, intricate network of blood vessels to deliver oxygen and other necessary things to the whole body. This network also removes the things your body doesn't need and takes them to organs that can get rid of the waste. The blood carries the oxygen, nutrients, and waste through your entire body. Now I will go into my first point of relevance between cardiovascular system and aging. Age-related changes in the cardiovascular system normally occur, with aging being an independent risk factor for cardiovascular disease. However, many other changes that are common with aging are due to or worsened by modifiable factors. The effects of aging are widely diverse and can be identified at the molecular, cellular tissue, organ, and system levels as contributing to the altered function of the cardiovascular system. Next, age-related heart structural changes. Structural changes with aging involve the myocardium, cardiac conduction system, endocardium. There is a progressive degeneration of the cardiac structures with a loss of elasticity, fibrotic changes in the valves of heart, and infiltration with amyloid. The age-associated structural characteristics that have the greatest impact involve the contractility of the heart left ventricle wall. The pumping capacity of the heart is reduced with age due to a variety of changes affecting the structure and the function of the heart muscle. Evidence suggests that between the second and the seventh decade, an increase in the left ventricular posterior wall thickness of approximately 25% occurs. This increase in heart mass, for the most part, is due to an increase in the average myocyte size, whereas the number of myocardial cells declines. The decline in left ventricular compliance provides an increased workload on the arteria, resulting in the hypertrophy of the artery. The third is cardiac conduction system. Cardiac conduction system is affected by the decrease in the number of pacemaker cells in the sinoatrial node with age. Beginning by age 60, there is a pronounced decrease in the number of pacemaker cells in the sinoatrial node, and by age 75, less than 10% of the cell number found in the young adult remains. With advancing age, there is an increase in elastic and collagenous tissue in all parts of the conduction system. Fat accumulates around the synovial node, sometimes producing a picture of complete separation of the node from the arterial musculature. The conduction time from the bundle of his to the ventricle is not altered. Valves. An age-related increase in valvular circumference has been reported in all four cardiac valves, which is aortic semilunar valve, pulmonary semilunar valve, bicuspid valve, tricuspid valve, with the greatest changes occurring in the aortic valve, the valve between the left ventricle and the aorta. Calcific deposits frequently are present on one or more aortic valve cusps. These changes do not usually cause significant dysfunction, although in some older adults, severe aortic valvular stenosis and mitral valvular insufficiency are related to degeneration changes with age. Clinical heart murmurs are detected more frequently. Myocardial subcellular changes. The nucleus containing DNA becomes larger and may show invagination of its membrane. The mitochondria show alteration in size, shape, crystal patterns, and metric density, which reduce their functional surface. The cytoplasm is marked by fatty infiltration or degeneration, vacuole formation, and a progressive accumulation of pigments such as lipofuscin. The combined age-related changes in the subcellular compartments of the cells result in decreased cellular activities such as altered homeostasis, protein synthesis, and degeneration rates.
Assalamualaikum, medium. My name is Muhammad Akmal bin Zulkifli. I will to continue age-related change in the blood visual. First, the aorta become the thicker, stiffer, and the less flexible. This is properly related to change in the connective tissue of the blood visual wall. The make in the blood pressure higher, and the make the hair work too hard, which may lead to hypertrophy of the microbiome. Second, artery thicken and the stiffen. In general, most older people have the moderator to become the less sensitivity, which the aging possibly explaining why many older people have the aesthetic hypertension. Third, the thickening of the basement membrane of the capillary wall means delivery oxygen and nutrition to slower, and that younger people, although there is some evidence suggest this effect modified with higher level and exercise. For the wall of the valve may become the thicker with age because the increase in the connective tissue and the calcium deposit, and the valve becomes stiff and the incomplete varicose vein may develop. Heart rate. As age, one of the most notable change in the cardiac system in the decline in maximum heart rate. The reduction in maximum heart rate is thought to be due to change the autonomic nervous system, along which it relates decrease in the number of cells in the synovial node. First, constitute of reduction in maximum heart rate. Smaller aerobic workload possible in reduction in the extent to cardiac exertion that can be tolerated for a period of time. Third, slower aerobic perform is 19 years old, completed in the city marathon topically to do so in 7 and 8 hours. After that, elevation in contractility as vesicular wall. This is contribute to slowing of heart rate to lower VO2 max, and the result in a reduction in the aerobic workload possible. The blood in self change in slide which age. Normal aging causes a reduction to total body water. Consequently, in the less fluid in the blood stream to blood volume decrease. Second, red blood cells are produced more slowly in the response to stress to illness. The reduce this create a slower response to blood loss and anemia. After that, most the white blood cells stay at the same level, although the neutrophil decrease their number and ability to fight and of bacteria. This reduce the ability to resist infection. Is relate the cardiovascular change as an exercise. Moderate exercise is one of the best thing other person can do keep their health and the rest the body healthy. Life and factor such as physically activity and exercise have a significant impact not only on the prevent cardiovascular disease later in the life. First, long-lasting exercise training of several years and of decades associated with improved cardiovascular function later life. Physiotherapy. One need a acute rest. Other people live regularly, after a day, sleep faster at night, and wake up faster in the morning, as well rest and hours during a day. Second, nutrition food. Eat more fruit and vegetable regularly 3 times a day and follow the food pyramid. Third, sport and recreation. Active sport every day during in the morning. 4, no smoking and no alcohol. Not smoke and drink this alcohol bereft at the harmful of healthy. Conclusion. The main function of the cardiovascular system is the maintain homeostasis by circulating blood cell, the consume oxygen and the nutrient to organ and the tissue, as well the transport carbon dioxide and the other waste product to excreted by other body system. Like many others aspects, the physiology function difficult to determine. Ever change in the cardiovascular function are caused by normal aging or pathological process